Could you please stop sharing? I'll share on my slide after this. Can you share?
What I should do?
Uh, like, can you please stop sharing for now? So I can share our slides for about instructions and.
Sir, he wants to share the rules and regulations, sir, for during the meeting.
Oh, I don't
Only
know.
one slide. That's all, sir.
But I don't know where is that how to do.
Okay, sir. Then he can read it. Amal,
Yes,
read
ma'am.
it from your side. It is not.
Okay, thanks. So, warm good afternoon, good morning to all the participants. Welcome to another session on Faculty Development Program on Advanced Process Control, sponsored by AICTE Training and Learning Untitled Academy, organized by Department of Electrical Engineering and Department of Chemical Engineering, National Institute of Technology, Calicut. So, these are the rules and regulations for attending this webinar. By attending this webinar, you voluntarily agree to the terms and conditions set forth by AICTE and the complaints of the academia or industry offering this lecture. No contents of this webinar may be copied, recorded, or reproduced in any manner without the written permission of the AICTE and the complaints of the academia or industry offering this lecture. Please do mute your mic and camera at all times. Do not use the chat box for sending personal greetings. Use only to post your doubts on the topic. Do not click present now during the session. If you have any technical issues, make sure your internet connectivity is stable and then wait for 1 to 2 minutes. If the issue persists, use the WhatsApp group to address it. Our team will assist you. Participants must attend all the sessions and a test will be conducted at the end of the FTP. Those who get 60% marks in the test and attendance of above 80% will get the participant certificate. The session will be starting at 9:30.
Good morning.
Good morning to all. So, Antigapa Patel, coordinator of FDP, Department of EED and Department of Chemical Engineering. I welcome our speaker, Professor J. Prakash, Director, AIQPC Research Center, MIT Campus, Anna University, for this today's technical session, topic of recursive state estimation schemes and overview for the advanced sponsored online FDP of Advanced Process Control, APC 2021. I welcome you, sir. Let me introduce the speaker. Dr. J. Prakash is currently working as a professor in the Department of Instrumentation Engineering, MIT, Anna University. He is the director of AIQPC Research Center, Anna University. He is serving as an editorial member and reviewer of several international reputed journals. Dr. J. Prakash is the member of many international associations. He has authored and co-authored multiple peer-reviewed scientific papers and presented works at many national and international conferences. His contributions have acclaimed recognition from honorable subject experts around the world. He had delivered invited keynote lectures in the international conference, invited lectures in pre-conference tutorials, workshops, faculty development training programs, etc. He has done collaborative research with the Computer Process Control Group, Department of Chemical and Materials Engineering, University of Alberta, Canada. His research interest includes process control and instrumentation, constraint state estimation, nonlinear controller design, and data fusion. His notable contribution towards MIT is the establishment of state-of-art field-based laboratory and modernization of process control laboratory at MIT campus, Anna University. So I welcome you for today's session, sir. Now the session is over to you, sir.
Thank you, Dr. Kanai Lakshmi, for introducing me. At the outset, I would like to thank the Department of Electrical and Electronics Engineering and Department of Chemical Engineering for having given me this opportunity. I would like to thank the coordinators and of the department and the director of NIT for this opportunity. And a very good morning to one and all present here. And yes.
Video, sir.
Hello. Are you able to hear me?
Yes.
Yes, sir. Clear.
Thank you. Thank you. So in my today's presentation, I'm going to primarily focus on soft sensing and state estimation, but there my focus will be on recursive state estimation schemes, though there are batch and non-recursive and recursive state estimation schemes are proposed in the process control literature, but primarily I'm going to focus on recursive state estimation scheme. With University of Alberta, Department of Chemical and Materials Engineering, especially with Professor Sirisha, Professor Bia Huang, and with my supervisors, Professor Shankar Narasimhan and Professor Sachin Parvatan, I've worked in this domain extensively. The work that I had carried out, I'm mainly as a researcher, that I would like to present, I would like to share with the participants. So primarily, state estimation.
Sorry to interrupt you. Switch on your video also, please.
Hello.
Sir, sorry to interrupt you. Can you please switch on your video also? Hello, sir.
Yeah.
Could you please switch on your video also?
Oh, you want to switch on my video? Okay.
Yes, sir.
So how to switch on the video? 1 minute. Let me see.
Start video, sir. The start video button is available.
Start video. Okay. Is it fine? So now you're able to see me?
No, sir.
Huh?
Yes, sir.
Yes, sir. Sir.
Okay, great. Okay.
Yes.
So
Thank you, sir. Thank you so much.
yeah, thank you very much. So my primary focus will be on recursive state estimation scheme, and so state estimation. It's an important, what I would say, it's an active research area, and many recursive state estimation techniques under stochastic framework have been proposed in process control literature. So recursive state estimation technique under deterministic framework also have been proposed, but in my today's presentation I'm going to focus on stochastic framework. So I will explain in detail about the framework in my subsequent slide. So recursive state estimation techniques under stochastic framework will be primarily discussed in today's presentation. And the recursive state estimation technique and the stochastic framework can be classified into unconstrained state estimation and constrained state estimation. So there are the subclassifications like unconstrained and constrained state estimation. Under unconstrained state estimation, for linear systems, Kalman filter is extensively used. Linear systems. For linear system, Kalman filter is extensively used. And for nonlinear systems, there are many state estimation techniques available in the literature. They are extended Kalman filter, unscented Kalman filter, ensemble Kalman filter, and particle filters. And of course, there are many other filters available, but the one which I have extensively worked, so that I would like to present in today's presentation. But of course, there are other variants available in the process control literature. So under unconstrained state estimations techniques, for linear systems, we have Kalman filters. For nonlinear system, we have extended, unscented, ensemble, and particle filters. And Kalman filters, for like it's widely used for linear systems, and Kalman filter will generate unbiased minimum variance estimate. For linear system, Kalman filter is the optimal estimator. And for nonlinear systems, there are many suboptimal filters proposed in the literature. There are many suboptimal filters. For example, Kalman update type filters. For example, the extended Kalman filter, unscented and ensemble Kalman filters. And of course, particle filters, again, for nonlinear, non-Gaussian systems, particle filters are widely used. But in my lecture, I will explain in detail about the various techniques that are proposed in process control literature. That I will discuss in detail. And moving to constrained state estimation, we have RNDDR, URNDDR. So if I expand this acronym RNDDR, it's a recursive nonlinear dynamic data reconciliation. Recursive nonlinear dynamic data reconciliation. This is unscented recursive nonlinear dynamic data reconciliation. And this can be viewed as, this RNDDR and URNDDR can be viewed as constrained versions of EKF and constrained version of UKF. So you can visualize it as basically a RNDDR as a constrained version of EKF and URNDDR as a constrained version of UKF, and constrained versions of UKF and PF have been proposed in process control literature. So also constrained versions of EKF, UKF, ENKF, and PF are also available in the process control literature. And these are widely used in not only in process control application, in many other applications in electrical engineering as well as mechanical engineering and aerospace. So the state estimation techniques have been widely used in different applications. And from the process control point of view, let me explain why do we need this estimation techniques, applications and all in the subsequent slide. So primarily, like the examples which I have chosen, they are from process control domain. Of course, like this can be applied, the techniques can be applied to other engineering problems, electrical, mechanical, aerospace problems. Let me explain the sequential estimation problem. That is the recursive estimation problem which we have to solve. So the primary objective of a state estimation problem is basically like we want to find the conditional probability density function that is x of k given yk. P of xk given k is nothing but the posterior distribution of the state. So this is basically P of xk conditioned on yk. What I mean by here is I wanted to find this, I want to determine the conditional probability distribution of x by making use of all the available measurement up to time k. Y superscript k is nothing but the available measurements. All the available measurements I would like to use and try to determine the unknown variable, which is here x. So this x is considered as a state variable or a hidden variable which is not directly available for measurement. X is an unknown variable, not directly available for measurement. But using the available measurement and the mathematical model, we would like to determine the posterior distribution of state. That is basically the sequential estimation problem that one has to solve. And in order to solve this problem, what is required is we need the initial state distribution P P of x comma P of x0. So this is basically the initial state distribution is required, and then we need a state space model and measurement. So given the initial state distribution, the state space model of the system, be it a linear system or nonlinear system, and then the measurement sequence, that is available measurement sequence, one can find the conditional posterior distribution of state. So that is possible. Here, P of x0 is nothing but the initial state distribution, and P of xk given xk minus 1. This is what we call it as state transition density, or a probabilistic representation of a state model. So we need a model. We need a mathematical model of the system. Without a model of a system, one cannot implement, one cannot solve an estimation problem. So we need a model, especially what is required is a state space model. And P of xk given xk minus 1 is the conditional. This is basically a probabilistic representation of a state model. And P of yk given xk is basically probabilistic representation of your measurement model. So state model and measurement model together constitute a state space model. So what is required is basically a probabilistic representation of a state model and a probabilistic representation of your measurement model. So that in state estimation literature, it is called state transition density and likelihood function. And so with the help of given a state space model and the available measurement here, measurements at different time instant, from first sampling instant y of 1, second sampling instant up to yk. So using all the available measurement and the model of the system and the initial state distribution, we are going to construct the posterior distribution of the state. So this is nothing but the sequential estimation problem which one has to solve. And in this slide, what I had explained is the solution to the sequential estimation problem. So our interest is to find the posterior distribution of the state vector, which can be determined in two steps. They are nothing but the prediction step and the update step. And you can see on the top left corner, you can see that logo, a predictor corrector. So this is basically, essentially, this is sequential estimation problem. It's a predictor corrector approach where you will be able to find the posterior distribution of the state can be computed in two steps. They are nothing but the prediction step and the update step. So at any given time step, at any given time instant, what you will do is that you will do a prediction and then you will do a correction at any given time step. So in the prediction step, what we try to do is we try to determine the prior density of x, P of xk given yk minus 1. This is what we call it as prior distribution. So prior distribution of your x. So that one can determine by propagating here. So here this is nothing but a famous Chapman-Kolmogorov equation. By propagating the posterior distribution of x at previous time instant, P of xk given yk minus 1 is posterior distribution of state at time k minus 1, at discrete time instant k minus 1. This is P of xk given yk. Here you see it is P of xk minus 1, given yk minus 1. So this is posterior distribution at previous time instant. By propagating the posterior distribution of x at previous time instant through a mathematical model, P of xk given k minus 1 is a probabilistic representation of a state model. So by propagating your the posterior distribution at previous time instant, and by solving this Chapman-Kolmogorov equation, what we get is the prior distribution. So prior distribution is nothing but the predicted estimate of x using all the information available up to time k minus 1. So that is your one step ahead predicted estimate of x, which is an unknown variable. So with the help of a model, you're going to do a one step ahead prediction. Not only the predicted value of estimate, you will determine how much is the error in the predicted estimate. So that is basically the distribution. So not only you will know the predicted value of estimate, how good is your estimate? How much is the error in the estimate? That is basically the prior distribution of X. And so this is basically in the prediction step, one will get to know the point estimate and how much is the error in the estimate. And in the update step, we are going to apply the famous Bayes rule. So your posterior density, which is of interest, which has to be finally computed, that is proportional to likelihood times prior, which we have determined from the prediction step. So P of xk given yk minus 1 is available. And then this is nothing but P of yk given xk is nothing but the probabilistic representation of your measurement model. So by evaluating this likelihood function, one can evaluate, given a measurement model, one can, and the statistic of the measurement noise, one can evaluate this likelihood function. Then what we are trying to do is by applying a Bayes rule, as and when we get the measurement, we modify the prior distribution by applying the Bayes rule. As a result, what we get is the posterior distribution of the state. So in all the filters, that is in Kalman filters, extended Kalman filter, uncentered, and in ensemble Kalman filter, what we do is we do a prediction and a correction. In fact, in TF also we do a prediction and a correction. In all the recursive state estimators, this prediction and correction is happening. For the prediction step, we make use of a model, the mathematical model of a system. It could be linear or a nonlinear system. And in the correction step, we make use of the available measurement. So we need a model and a measurement. The model is used in the prediction step, and in the correction step, we make use of the available measurement. So we modify the predicted estimate. So we correct the predicted estimate. The correction is happening. Basically, update step is basically a correction step where we correct the predicted estimate by making use of the available measurement. So this is how the posterior distribution of state has been computed in all the algorithms. That is right from extended, uncentered, wherever you see. So this is nothing but a sequential estimation problem. Once you have the conditional posterior distribution of the state, then we can determine point estimates, such as minimum mean square estimate. You can find a minimum mean square estimate or a map estimate, and also one can determine the accuracy of the state estimate, which is nothing but the covariance. So you can find mean, mode, median, and then also one can get how good is the estimate once you have the posterior distribution of the state. So in a sequential estimation problem, let me again emphasize, we use a model, a stochastic model of a system, not a deterministic model. We use in a stochastic framework, we use a stochastic model. So that's why here the probabilistic representation of state model is used in the prediction step, and the probabilistic representation of your measurement model is used in the update step. So we need the stochastic model of a system, not a deterministic model, and also we make use of measurements. Measurements are corrupted by noise. So it's basically the measurements that are available. Definitely, what will happen? There could be random errors present in the measurement. So the measurements and the models are used to determine the posterior distribution of the state. And once we have the posterior distribution of state, then we can determine point estimate. That is, x hat of k given k is nothing but expected value of xk given yk. So this is nothing but your point estimate, the mean, a mode, and the accuracy estimate. Everything can be easily computed once we have the posterior distribution of the state. So in these slides, what I have explained is the solution to a sequential estimation problem has been explained. And for this, what is required is an initial state distribution, mathematical stochastic model of a system, and measurements. So here in this slide, what I would like to explain is the stochastic model of a system. Here, what you see here is a nonlinear state model. That is your equation 1, and the measurement model is presented in equation 2. So equation 1 and 2 together constitute what I would say a nonlinear state space model of a system, state space model of a nonlinear system. And your f and h, they are nothing but f is nothing but your state transition function, which I'm assuming that it is known actually. F is known. If f is not known, then you have to like with help of say system identification technique, you have to determine the value of this function f. So I'm assuming throughout my lecture, I'm assuming that f is known, h is known, but of course f is f is a function of xk minus 1 and uk minus 1. And another assumption what I'm making here is this w affects x in an additive fashion. Similarly, v of k affects your measurement model in an additive fashion. If it is going to affect in a non-additive fashion, then also like you can use Kalman filters, extended Kalman filters, but slightly what is required is the algorithm has to be modified. So I'm assuming that w and v, this w is nothing but uncertainty associated with the state model. W of k captures the uncertainty associated with the state model, and vk captures the uncertainty associated with the measurement model. So this is nothing but a discrete nonlinear state space representation, nonlinear stochastic state space model. So I'm assuming f is known, h is known, and y is also available. So measurements are available. So y, f, and h are known, and then the statistical properties of w and v also in my presentation I'm assuming that it is known. And the expected value, the mean value of wk is 0. The expected value of vk also assumed to be 0. And the second moment of wk and vk, they are nothing but the covariance matrix. Here I'm assuming that the covariance matrix is constant q and r. So essentially the assumption what I'm making in this slide is w and vk, that is your the process noise. W is called a process noise, vk is called a measurement noise. This process noise and measurement noise, they follow a normal distribution with mean 0 and variance q, that is for wk, and for vk it is mean 0 and variance is r. So this q and r are nothing but the covariance matrix associated with wk and vk, and I'm assuming that it's mean 0. That means this wk will not cause a mean shift in x. Similarly, vk will also not cause mean shift in y, but the spread of the distribution, the spread of x and spread of y, that will get affected because your q is assumed to be non-zero and r is also assumed to be non-zero matrix. So that the distribution here what I've shown is the distribution of w and distribution of v. You can see that the mean is 0, the mean is 0, and the spread of the distribution you can see here it is plus or minus 3, and here plus or minus 0.2. So this is basically a histogram plot of a w and v are shown here. So the underlying assumption here is I'm assuming that f is known, h is known, w and vk, they're going to follow a multivariate normal distribution, and the mean is 0 and variance I'm assuming to be the covariance matrix q and r. These are all known, but if they are unknown, then there are methods available to estimate the values of covariance matrix and covariance matrix, that is q and r, but that I'm not going to focus in my today's presentation. And the second assumption what I'm making is, so this is basically about the mathematical model of the system, because in my earlier slide I had mentioned that we need a mathematical model. So the mathematical model of the system has been explained, and then I'm assuming that the initial state distribution also will follow a multivariate normal distribution with mean x hat of 0 and covariance matrix p of 0. So this is with regard to the initial state distribution. And about the model, the mathematical model, the form of the model that, okay, I'm going to use in constructing a state estimator. And the third assumption what I'm going to make is the autocorrelation of W and V. They are uncorrelated, I'm assuming. So this WK and VK are uncorrelated sequence. It's a noise sequence. It's uncorrelated. So that is what, and you can here the autocorrelation plots of W and VK are shown here, and you can see here, and so it's an uncorrelated sequence. So that is basically the assumptions that we make, and here, so as a result, what you get is basically the covariance set. Here we are assuming WK WJ. So at for J not equal to K is 0. So these are some of the underlying assumptions we make, and then the cross correlation between W and VK is also there. There is no cross correlation between W and VK. So it's an uncorrelated sequence, and then the cross correlation between W and V. There is no cross correlation between W and V. So these are the underlying assumptions, and so the first filter that I'm going to focus is Kalman filter, and this was proposed by Professor Kalman, and for linear systems. For linear systems, a Kalman filter is widely used. It's a predictor corrected approach. And what had been presented in this slide is the linear state space model. This is basically a stochastic linear state space model. So this is this is your state model and your measurement model. Together they constitute the state space model of a system. And here what is important here is, in the case of a Kalman filter, let's see how the prior and posterior distribution are approximated. The reason why, because I said like two things we have to compute. One is the prior distribution, the other one is the posterior distribution. So in my subsequent slides, I'm going to explain how the prior and posterior distributions are approximated in different filters. So first, let's focus on Kalman filter, which is applicable for linear systems. So the prior distribution and posterior distribution in the case of Kalman filter, they will follow a multivariate normal distribution. And we know very well that a multivariate normal distribution can be completely characterized with the help of first two moments. The first moment is nothing but your mean, and your second moment is nothing but your covariance matrix. So x hat of k given k minus 1 is your first moment with respect to the prior distribution, and pk given k minus 1 is your second moment with respect to your prior distribution. So one can easily show that the prior distribution and posterior distribution will follow a multivariate normal distribution, and the first moment of your posterior distribution will be x hat of k given k, and your pk given k is nothing but your second moment of your posterior distribution. The derivation I'm skipping, but one can easily you can easily solve this Chapman-Kolmogorov equation, and then we can show that the prior and posterior distribution analytically it can be shown that they will follow a multivariate normal distribution. Now, so and let me again emphasize that multivariate normal distribution can be completely characterized with the help of first two moments. The first moment is your mean, and second moment is your covariance matrix. And here what I have shown is the algorithm, the Kalman filter algorithm. So at each and every time step, what we determine is we determine the prior distribution. The prior distribution happens to be like it will follow. In the earlier slide, I had mentioned that it will follow a multivariate normal distribution. So that so we have to compute in the prediction step. We have to compute one step ahead predicted estimate. So x hat of k given k is nothing but the one step ahead predicted estimate, and pk given k minus 1 is nothing but the error in your predicted estimate. How much is the error in your predicted estimate? So at the end of the prediction step, we will generate one step ahead predicted estimate of your state variable, and how much is the error in the predicted estimate. That you can compute using the two equations which I've shown here. So x hat of k given k minus 1 can be computed using this, and pk given k minus 1 can be computed using this relationship. So for which what is required is we need the mathematical model 5 gamma, and then you need q. U is nothing but your input actually. So phi gamma are nothing but your parameters associated with your state model, and Q is nothing but your the second moment of your W, that is model uncertainty. U is the input, and xk given k minus 1 and pk given k minus 1 are nothing but your previous estimate. So with the help of this, one can compute the first moment and second moment. And in the correction step, what basically we are going to do is we're going to correct our predicted estimate. So the predicted estimate happens to be x hat of k given k minus 1 and x hat of k given k minus 1 plus some correction. So we are going to correct our predicted estimate. So with the help of a model, we will predict, and then using the available measurement, we will correct. So this is basically the correction which we are going to carry out. As a result, what we get is an updated estimate, which happens to be the first moment of your posterior distribution. Similarly, we are going to correct our pk given k minus 1 by this factor I minus kc. And as a result, what we get is pk given k, which is nothing but the second moment of your posterior distribution. So at any given time step, we do a correction, prediction, and a correction. This is going to happen recursively. A prediction equations are shown, and with the help of a predicted estimate and the measurement. See here, what I've shown here is in the ek given k minus 1, k times ek minus 1 is the correction which we are going to carry out, and ek given k minus 1 can be computed using this relationship y of k minus c into x hat of k given k minus 1. This y is nothing but the available measurement. So what we have is available measurement. Using the available measurement, and c times x hat of k given k minus 1 is your predicted output estimate. C is nothing but your measurement matrix. X hat of k given k minus 1 is your predicted estimate. So this is nothing but your predicted output. One step ahead predicted output. And the difference between the actual measurement and the predicted output is your residual. So ek given k minus 1, k times ek given k minus 1 is the correction which we are going to do. And thereby what we get is an updated estimate. So this k is nothing but your Kalman gain. So k is nothing but your Kalman gain, and Kalman gain can be computed using this relationship pk given k minus 1 c transpose times cpc transpose plus r volumes. So this, with the help of this relationship, one can determine the Kalman gain. So the algorithm. So easily one can implement the algorithm. So there are two steps, and this you do at each and every time step. In the next time step, we will determine x hat of k plus 1 given k and pk plus 1 given k, and using the available measurement, we will determine x hat of k plus 1 and p of k plus 1 given k plus 1. So in a nutshell, what I can say is that in Kalman filter, the prior and posterior are approximated as a multivariate normal distribution. And with the help of the mathematical model, one can determine the first and second moment of prior distribution. Similarly, first and second moment of your posterior distribution. So we use a model, measurement, and the uncertainty associated with the model, that is your Q and R. So with the help of all this, one can determine the unmeasured variable, that is this x hat of k given k minus 1 is the unmeasured variable, which is not directly available for measurement. So we are trying to estimate the unmeasured variable. So with the help of what? A mathematical model, available measurement, and uncertainty associated with the model and the measurement. So this is about a Kalman filter, and one can easily show that Kalman filter is will generate an unbiased estimate, and the variance associated with the estimate is also minimal. And now what I'm going to do is that I'm going to explain nonlinear filters that are available in the literature. Before discussing about nonlinear filters, first I would like to explain how to compute the statistics of a transformed random variable that undergoes nonlinear transformation. So I'm going to explain that in this slide. So here I'm assuming that this x is a random variable. X is nothing but an input, and f is a function. So this x is a random variable. It undergoes a transformation, a nonlinear transformation, and as a result, what you get is an output y, which can be visualized as a transformed random variable. So x is an input, y is an output, and x undergoes transformation and a nonlinear transformation. So I'm assuming this function is a nonlinear function. So x undergoes a nonlinear transformation, and as a result, what you get is an output which can be visualized as a transformed variable. It's an output variable is a transformed variable, and what is our interest is, given the function f, let's assume that f is known, and also the statistics of the random variable x. Our interest is to find the statistics associated with y. That means the first moment, second moment, third moment, other moments we would like to determine given the function f and x. So there are three ways by which one can determine this, which I explained in this slide. Let's focus on the first part. The first part, let's assume that I know the mean, and let's assume that this x is going to follow a normal distribution. Let's assume that x is going to follow, and I know the first and second moment of x. So what I'll do is, in order to compute the first and second moment of y, that is expected value of y and covariance of y, given expected value of x and covariance of x and the function f, what we try to do is we randomly draw samples from x. We know the distribution of x. Just now I had mentioned that x is going to follow a normal distribution. You can assume a distribution for x. Let's assume that x is going to follow a normal distribution. So randomly I'm going to draw samples from this distribution, propagate each sample through my function f, and what I get is a sample points associated with this x. So I'll draw samples randomly from this distribution, and each sample I will propagate through my function f. Then what I get is a corresponding output. What we call it as a sample points associated with y. So what I have is, for each x, I'll get for each sample point associated with x, I'll get what a sample point associated with y. Then what you can do is one can determine the mean and the covariance once we have the sample points. So once we have the sample points, we know how to compute the mean and the covariance. So this is what we call it as a sampling based approach. So we will draw randomly samples from the distribution x, and we'll propagate, and this is being adopted. This approach is being adopted to determine the moments of the distribution y, that is first and second moment. This is being used in particle filter. In an extended Kalman filter, what we try to do is, in the case of an extended Kalman filter, we assume that the distribution of x to be normal. So as a result, we know its first moment, which is x bar, and the second moment, which is your piece of given x. This is nothing but the covariance matrix associated with x. So we propagate here, in the case of an extended Kalman filter, we propagate only the mean x bar through the function f, and thereby we compute y bar. So here the mean of the mean, it's propagated through the function f. As a result, what we get is we compute this y bar. And you can see here the true mean is shown in the true mean is here, whereas the estimated value is far off from the true value. So that means there exists a bias here. And the covariance matrix that is shown as an ellipse here, that is the magenta one is the estimated one, and the true one is your the black one. You can see that there is an underestimate of covariance. So you can compute mean and covariance, that is the moments, the first moment and second moment of the distribution using this. So here what we are trying to do is we are trying to approximate the function. We are trying to linearize this function f around an operating point x bar, and as a result we compute this matrix A, that is nothing but dou f by dou x bar, dou f by dou x evaluated x bar. So as a result, what we are trying to do is, in order to compute the covariance matrix, we try to linearize this nonlinear function around x bar, and with the help of that that relationship, we try to compute the covariance matrix. As a result, what we get is an underestimate of covariance. This is being used in extended Kalman filter. Basically, what we try to do is we try to linearize the nonlinear system around its previous estimate, and then we apply Kalman filter. That is what is extended Kalman filter. So this is in order to find the moments in extended Kalman filter, what we try to do is we try to approximate the function f around its previous estimate. Whereas in the case of an uncentered Kalman filter, this is what we call it as an uncentered transform. Here, in uncentered transform, we won't draw randomly. We won't draw samples randomly from the distribution x. In the first case, I said we'll randomly draw samples from x, whereas here in uncentered transform, Professor Ullman has given a procedure to deterministically draw samples. That means he has come up with a procedure by which what will happen using this uncentered transform technique, you can draw samples deterministically, and you can propagate each sample point through the function f, and what you get is a transform sample points, and also there is a weight associated with each sample points, and then you can compute the moments, that is your first moment and second moment, using the sample points and the weights. And what you see here is the green one is the computed value of mean, and the black one is the true value. You can see that almost they are same, and similarly the estimate of the covariance matrix, the true one and the estimated one, they are matching. So here this approach is being widely used. This uncentered transform technique is widely used in UKF. That uncentered Kalman filter was developed using this concept. So at each and every time step, what we are trying to do is we are trying to find the moments of the transformed random variable. Where exactly this we are using, let me explain. So what we are trying to do here is we are trying to compute the moments of the prior distribution. The moments of the prior distribution, that is first moment and second. So you can imagine this is y and this is your some function of x. So you can imagine that this is y, and then the right hand side is what is f of x k. So this is basically your these are inputs which undergo some nonlinear transformation. As a result, what you get is a transformed variable x. So there are three ways by which one can determine this. So this is so now in this actual sampling approach is widely used in it's being used in particle filters, whereas the random sampling approach is used in particle filters. Approximating the function and then trying to apply Kalman filter is widely used it's used in extended Kalman filter, whereas is using this uncentered transform techniques, UKF uncentered Kalman filters are developed. So now let me explain quickly how the prior and posterior distributions are approximated in these filters. First, let's focus on extended Kalman filter. So in extended Kalman filter, I'm going to the prior and posterior, they are approximated to be Gaussian. Whereas in Kalman filter, I had mentioned that they follow a normal distribution. We can show that analytically that prior and posterior will follow a multivariate normal distribution, whereas here in extended Kalman filter, they are approximated to be Gaussian. So for that, what we try to do is we try to linearize this function f and h around its previous estimate. So we have to linearize this the nonlinear state transition function and the measurement model, and then we will apply Kalman filter. So as a result, the prior and posterior are approximated to be Gaussian, and the prior distribution. So we know that since they are approximated to be Gaussian, so so they can be described completely with the help of first and second moments. So they are nothing but predicted estimate and the error associated with the predicted estimate. This is your corrected estimate and the error associated with your corrected estimate. Mainly for the covariance update in extended Kalman filter, for the covariance update, what we try to do is we try to do a Taylor series expansion and then linearize the nonlinear model around its previous estimate. Previous estimate is x hat of k given k moments. So as a result, if you want to implement an extended Kalman filter, it requires evaluation of Jacobian dou f by dou x. Then only we can find phi of k. And especially for large dimensional system, the dimension of the system is very large. Covariance computation, there is Jacobian evaluation is computationally prohibitive. And another disadvantage is this f should be smooth and at least once differential. So smoothness requirement on system dynamics. Discontinuities are not permitted. So these are all the underlying assumptions involved in extended Kalman filter. So the function f, that is your state transition function, and here should be smooth and at least once differentiable. And another assumption what we are trying to do is, in order to compute the expected value of x, we propagate the expected value of x through a function f. And so as a result, what you get is you won't get an unbiased estimate. There will be a biased estimate. So these are all some of the disadvantages associated with the extended Kalman filter. For a discontinuous system, if there are discontinuity, then Kalman filters cannot be applied. For large dimensional system also, computation of this Jacobian, it's computationally prohibitive. So for large dimensional systems, extended Kalman filters are not preferred. And also, if the nonlinearity is very high, and because of this assumption, like to compute the expected value of x, we propagate the mean and the first moment of x through the function f. So because of this approximation, you will not get for a highly nonlinear system, you won't get an unbiased estimate. So the other name for extended Kalman filter is derivative based filters, and derivative free filters have been proposed in the process control literature. They are nothing but uncentered Kalman filter and ensemble Kalman filter. Here, even the Jacobian evaluations are, there is no need to compute Jacobian in the case of uncentered Kalman filter and ensemble Kalman filter. But they are similar to that of extended Kalman filter. The reason why, because they make use of only first and second moments. And the underlying assumption here is we're going to compute the covariance matrix using sample statistics. So it's a derivative free filters, and here we are going to compute the moments, first and second moments, using sample statistics. So let's focus on first on uncentered Kalman filter. So in the uncentered Kalman filter also, the prior distribution p of xk given yk minus 1 and posterior distribution, they are approximated to be Gaussian. So here also we are trying to approximate the distribution to be normal, multivariate normal, okay, both prior and posterior. But the way in which the distribution is, what I would say, represented. So we represent this multivariate normal distribution with the help of 2n plus 1 finite sample points. It's okay, and there is a so with the help of this 2n plus 1, i varies from 0 to 2n. So with the help of 2n plus 1 sample points, we try to represent this distribution. So the way in which the distribution is represented. So with the help of finite sample points and a weight associated with each sample point. WI is nothing but the weight associated with the sample. So the way in which the distribution is represented, that is the key contribution. Professor Ullman, with the help of finite sample points, will be able to represent this multivariate normal distribution. So here the deterministic sampling approach is used, whereas in the case of an ensemble Kalman filter, here again we try to approximate the prior and posterior distribution with the help of finite sample points, and the weight associated with each sample point here is 1 by n. The reason why it is 1 by n, because we randomly draw samples from the distribution, from the initial state distribution. So here the weight associated with each sample point is 1 by n, because the sampling approach that is being adopted here is a random sampling approach, whereas in the case of an uncentered Kalman filter, the a deterministic sampling approach is used. So to draw samples from a multivariate normal distribution. So far what we have seen is variants of Kalman filters, starting from extended, ensemble, and then uncentered Kalman filters. So they are all they belong to a Kalman update type filters category. And in this slide, I had explained the limitation of Kalman update based filters. In Kalman update based filters, we assume that the prior and likelihood distribution are assumed to be Gaussian. This is the underlying assumption. And then to compute the Kalman gain, in all the filters we compute the Kalman gain, and Kalman gains are computed using the covariance matrices. So the underlying assumption here is prior and likelihood are assumed to be Gaussian. That's a limitation of Kalman update based filters. The next filter which I'm going to explain is a particle filter. In particle filter, we're not going to make any assumptions with regard to the distribution of prior and likelihood. We're not going to make any assumptions. And so here, what I've shown here is the posterior distribution is likelihood times prior, and prior in Kalman update based filters, it is assumed to be Gaussian. And your likelihood also assumed to be Gaussian. So as a result, product of two Gaussian is Gaussian. We assume that the posterior distribution also assumed to be Gaussian, or it is approximate to be Gaussian. Whereas in particle filters, we are not going to make any assumption. That's the biggest advantage of particle filters. So if the distribution is non-Gaussian, then it can very well be approximated using particle filters. Let me explain the particle filters. In particle filters, what we assume is we should know first the initial state distribution. Be it Kalman filter or extended Kalman filter, we need an initial distribution. So let's say we are able to draw samples from an initial distribution. Then what we do is that we propagate each sample point through the model. I'm assuming that f is known. So we will propagate each sample point. So the sample points are shown here. So we will draw randomly samples from the initial state distribution. Then we will propagate each samples through the model. And then what we get here is a transformed sample points. They are nothing but the predicted sample points, predicted particles. You can see the distribution of the x. So that is basically the spread of the distribution is shown here. Then at time step k, yk is available. So that is measurements are available. With the help of measurements, I can determine this value. This error can be computed. I know y of k. This is nothing but your predicted output. I'll find the difference between the actual measurement and the predicted output. So thereby what I get is E superscript I. Using this relationship, one can determine what the weights associated with each sample point. And then based on the weight, magnitude of the weights, it can be ranked as low, medium, or high. So let me explain. If the if the like various colors here are indicated, blue, and red. The blue, if the here you can see that if the some of the blue ones here, it has been indicated as low importance region, and then the red ones are high importance region. So particles which are lying close to the measurement, you can see here, these are all red ones. So particles which are lying close to the measurement, they are considered, they are lying in the high importance region. And particles which are lying far away from the measurements, those are called, those particles, they are lying in the low importance region. And then this, okay. So depending upon how close is your predicted value to the actual measurement. If this is close, then your error is small. As a result, exponential of something that will be close to 1 actually. So they are nothing but, this W is nothing but your importance, right? Depending upon how close is your predicted value to the measurement, accordingly the weights will change. And if it is lying very close, then those particles are lying in the high importance regions. And if it is close to 0, the weights are close to 0, then the particles are lying far away from the importance region. So based on this, based on this weights, what we are going to do is we are going to carry out corrections. Particles which are lying in the high importance region. So these are particles, here you can see particles which are lying. So they are lying in the low importance, those will be discarded. And particles which are lying in the high importance regions will be replicated. So this is what we call it as a correction step. So first what we do is, we draw randomly samples, propagate each samples through a model. Then what we get is a predicted particles. Measurements are available. Using the measurements, we will compute the weights. Then we'll rank them, whether they are lying in the low importance regions or high importance region. And then based on the weights, what we try to do is we do a resampling. In the resampling approach, we will discard particles which are lying in the low importance regions and replicate particles which are lying in the high importance region. So, and as a result, what we get is here the updated distribution of your X, and then we will propagate them, those updated particles, through a model. And what we get is a predicted estimate at next time step. Measurements will be available at that time instant. Using the available measurements, we will compute the weights, we will rank them, and then we will do correction, and then we will put it. So this is how in particle filters we make use of a model and measurements and carry out again prediction and correction. So in a nutshell, what I have explained so far is how the prior and posterior distributions are approximated in Kalman filter, extended Kalman filter, unscented Kalman filter, and in particle filter. So the reason why, because in order to compute the posterior distribution of X, what is required is we have to compute prior distribution, and then you have to evaluate this likelihood function, and that way what we get is the posterior distribution of state. So how the prior and posterior distribution are approximated, one should know. So that I have explained. And then how to compute the moments, first moment and second moments of prior and posterior distribution for different techniques, that also has been covered. And the remaining part I'm going to focus on the applications. So the first application which I have chosen is basically, it's a constrained state estimation problem using ensemble filter. Hello. So here it's a gas phase reactor problem, and basically here what we have to do is we have to estimate the partial pressures PA and PB. These two are state variables, PA and PB are. We have to estimate the partial pressures PA and PB, and what is available to us is the total pressure. Total pressure is what is available. So the available measurement is total pressure, and the unknown variables are partial pressure A and partial pressure B. So with the help of the available measurement total pressure, we have to estimate the unmeasured state variables PA and PB. And when we estimate, the partial pressure should not go negative. So this is it's a famous two-state problem. It's a gas phase reactor. It's an isothermal batch reactor, and you can refer to the paper Rawlings 2003, and it's a famous benchmark problem. And first, what we tried is we designed and implemented an unconstrained ensemble Kalman filter. You can see here, when we tried to implement an unconstrained ensemble Kalman filter, it generated biased estimate. You can see here the evolution of process variable, evolution of partial pressure of A, and evolution of partial pressure B is shown here at different sampling instance. The true one is the red one is the true, and magenta and blue are estimated values for different sample size for n equal to 25 and n equal to 100. You can see here partial pressure should not go negative, but it is going negative here. And partial pressure B, it's not negative, but there is a there exists a bias between the estimated value and the true value. So you can see that significantly they are biased. So as a result, what we can come to a conclusion is, for this problem, when we try to implement an unconstrained version of ensemble Kalman filter, it generated a biased estimate, and also constraints are violated. That is, partial pressure is going negative. Then we came up with a constrained version of an ensemble Kalman filter, and the results are presented here. You can see that the partial pressure A, the evolution of partial pressure A and evolution of partial pressure B is shown here. You can see that the constraints are never getting violated. Constraints, and also your estimated value follows the true value. So we are able to generate an unbiased estimate, and so constraints are never gets violated. We get a non-negative estimates of partial pressure. So we came up with a constrained version of an ensemble Kalman filter, and here what we have shown is the spread of the particles. The spread of the particles at different time instant. You can see initially the spread is very large. As time progresses, what is happening is your spread is reducing. That means initially the variance is very high. The variance of the estimate is very high. Within 10 sampling instant, everything converges. You can see this is with respect to partial pressure A and with respect to partial pressure B. So what we can say is, so with the help of this compensation, that is prediction and correction, we're able to reduce the variance. And finally, what you get is, so here, the estimated value and true value, they overlap. So at different times, this is basically the spread of the particles, and you can say that the convergence is happening. And this for this now, we modified the update step. That I'm skipping because of amount of time. So we modified the prediction step, okay, and then in the update step, you can refer to the paper, the modification that we had proposed, and then which appeared in Industrial Engineering Chemistry Research. So modifications that you had proposed in the prediction step and correction step, and then we generated an estimate. And the second thing which we tried was, like, we implemented a particle filter with EKF as proposal on the same example. And then when we implemented particle filter also estimated what the estimated value of the partial pressure was found to be negative. You can see here. And the estimated value of partial pressure B is also significantly biased. So particle filter also is unable to generate unbiased estimate. So this is a particle filter with EKF as a proposal. Then we came up with a variation, like we proposed a new algorithm, a constrained version of a particle filter. And there, instead of using a extended Kalman filter, we used a constrained version of extended Kalman filter as a proposal. And when we used a constrained extended Kalman filter as a proposal, we were able to generate fairly accurate estimates, and the evolution of true and estimated value of partial pressure A and B are presented in this slide. You can see that the constraints are not violated. We were able to generate non-negative estimates of partial pressure. So these two examples, basically our interest is only the total pressure is available, but what is required is partial pressure A and partial pressure B. So we have developed a soft sensor. With the help of a soft sensor, we were able to estimate the unknown process variable, namely partial pressure A and partial pressure B, using the mathematical model and the available measurement, which is total pressure. So this is an example for soft sensor. And the next problem is like valve friction is a big problem in almost all. And as you all know that pneumatically actuated controller are widely used as a final control element in process industry. So sticky valve is a major problem, and then we solved valve friction problem using using state estimation approach. So in the presence of friction, which is nothing but a static friction, then what will happen? Your process variable will oscillate around the set point, which I have shown here. So as a result, your MV, that is your the output of the position. Here the MV is nothing but the position of the control valve, and OP is nothing but your computed value of position. So OP is nothing but computed value of position, and MV is nothing but the actual value of the position. MV will not follow OP in the presence of friction. So as a result, what will happen is your process variable will oscillate around the set point, which leads to large variance in the output, and also there will be degradation in the closed loop performance, because if the variability is very high, then the quality quality will get affected, the product quality will be affected. So which leads to degradation in the closed. But indirectly, what we get is a poor final product quality. So we converted this valve friction problem into an unknown input estimation problem. So we converted this sticky valve problem into an unknown input estimation problem. And by employing, so here, as I had mentioned in the earlier slide, in the presence of friction, MV will not follow OP. So we assume that some unknown input is affecting OP. As a result, MV is not equal to OP. So we converted this sticky valve problem into an unknown input estimation problem, and then by employing an unknown input observer and unknown input Kalman filter, we estimated this unknown input U tilde. So that's the key contribution of this particular paper, which appeared in JPC, Journal of Process Control. And then so we make use of the model and the available measurement. And then what we try to do is we try to estimate this unknown input. Once we have this unknown input, U tilde being estimated using Kalman filter, then we can determine the actual value of MV, because OP is known. OP is nothing but a controller output. U tilde is unknown. So OP plus U tilde will give MV tilde. So then once we know MV tilde, with the help of MV tilde and OP, one can detect and quantify friction. That in the friction literature, with the help of this OP MV plot, one can determine one can easily detect friction and quantify friction. So here what we have assumed is MV is not available, the actual position of the control valve is not available, and what is available is OP, and U tilde affects OP in an additive fashion, and we try to estimate this U tilde with the help of an unknown input observer. As a result, once we have estimated U tilde, we will be able to find the position of the control valve, that is the actual position of the control valve. So in the presence of friction. So once we have this OP and MV, we'll be able to detect and quantify structure, which we tried. And then we validated this on the flow control loop, which is available at University of Alberta. This was all these work which I had presented was jointly carried out with Professor Sirisha and with Professor Shankar Narasimhan. I would like to thank at this juncture Professor Sirisha and Professor my collaborators, Professor Shankar Narasimhan, Professor Sachin Patwardhan, and others, Professor P. Apong, for all the support they have extended during the visit to University of Alberta. So we validated this on a flow control loop. Here what we have shown is the OP-NV plot, and deliberately we introduced 2% friction, and then with the help of our algorithm we were able to quantify the friction. So 2% is the one which we have introduced, and the estimated value is close to the 2. The estimated value is found to be 2.1. So, and thereby we were able to quantify the amount of friction that is present in the flow control loop. So this is basically like with the help of this Kalman filter, we were able to detect and quantify the fault that is present in the system. That means the friction that is present in the system. Similarly, we came up with a fault tolerant control scheme also, like by employing a Kalman filter. What we did is and using an approach called JLR, that is generalized likelihood ratio approach, we were able to detect and determine the magnitude of the bias present in the sensors, actuators, and then subsequently what we did is by employing what the Kalman filter and the JLR approach, we were able to detect the time at which the fault has occurred, the type of the fault, its position and magnitude, and then using all this information, that is the type, position, and magnitude, we came up with a compensation scheme, and then we came up with a compensation scheme, and thereby we were able to correct the sensor output or the actuator output, and as a result, we were able to operate the plant without much degradation in control performance until scheduled maintenance of instruments are carried out. This is what we tried actually. So you can and this got published in Industrial Engineering Chemistry Research. So basically what we have employed here is an estimator and an FDA algorithm, and the FDA algorithm which we used is a GLR. So with the help of an estimator, we will estimate the current state of the system, and then the residual is, which is nothing but your measurement and the predicted value. That residual is being fed as input to your fault detection and identification block. So with the help of this GLR algorithm, we determine the magnitude of the fault. You can see here B hat is nothing but bias, B is nothing but bias in sensor, B hat is nothing but an estimate of the bias. Once you know the estimate of the bias, we will be able to compensate, and the compensated value goes to the control. So this we came up with an active fault tolerant control scheme by employing Kalman filter and JLR approach, and also it has been validated on a 3-time example here. So this is basically on a 3-time example we validated this. So with this, what I'll do is, and then subsequently, what we tried was, we came up with a multiple model approach based Kalman filters that, because of lack of time, I'm not going to explain. So we came up with a multiple model approach based Kalman filters, where first what we try to do is we try to approximate a given nonlinear system with the help of n local linear models weighted using fuzzy membership function, and for each local linear model we designed an estimator, and then we combined them and then developed a global estimator. This we validated on a CSTR example. So you can see here the results, the true value and estimated value. This is we were able to estimate the reactor concentration and reactor temperature for random step-like variation in the coolant flow rate. This is your input, and the unknown state variable is concentration. As we know that concentration is not directly available for measurement, so we assume that temperature only is available and the mathematical model of the system, and then we estimated the reactor concentration, which is an unknown variable, by employing Kalman Filter. And then so validated for different scenarios in the presence of unmeasured disturbance. We introduced a pulse-like change in the feed temperature, and then even in the presence of pulse-like disturbance, your Kalman filter is able to, the multiple model approach based Kalman filter is able to generate a fairly accurate estimate. Similarly, in the presence of bias also we tested. Even in the presence of bias, it's able to generate fairly accurate estimate. You can see the red one is the true and the blue one is the estimated value. So in a nutshell, like what I had explained is various recursive data processing algorithm, namely extended, uncentered, ensemble particle filters, and they can be used as a digital filter. The role of this digital filter is to cull out measurement noise. So with the help of this Kalman filter, you will be able to suppress the measurement noise. So that's the first application. And the second application is like you can use this to build a soft sensor. And the example which I had shown is with the help of the available measurement, that is total pressure, we were able to estimate the unavailable measurement, namely partial pressure A and partial pressure B. So one can easily build virtual sensors. And in process industries, mostly if you see the quality variables are not directly available for measurement, then we have to use analyzers. So instead of an analyzer, what you can do is you can employ Kalman filters, and then try to estimate the quality variables by employing soft sensors. And the next one is basically Kalman filter based FDA scheme, where here with the help of Kalman filters and GLR, MLR, we tried different approaches. We were able to assess the healthiness of the field instrument, kind of process doctor, where we will be able to detect and quantify faults in sensor, mainly drifts in sensors, bias in sensors, or a complete failure. Similarly, drifts in actuators, bias in actuators, or there could be leak detection in pipeline networks, or fouling, variation in heat transfer coefficients. All this can be estimated by employing what Kalman filter based FDA scheme. What I had not explained is state estimation based MPC, because in MPC, especially if you want to implement a state space model based MPC, then what is required is if you want to predict the future value of your state variable, you should know the current state of the system. So once you know the current state of the system only, then we'll be able to carry out future prediction of state variable. And there, state estimators are widely used. So we employed uncentered ensemble for hybrid systems. And then we came up with a state estimation based model predictive control. And with the help of the proposed scheme, the scheme which we had proposed, we were able to control the process variable at the desired set point. We were able to suppress the disturbance, reject the disturbance, and bring the process variable back to the set point. And also we integrated MPC with the FDA, and then we came up with a fault tolerant control based MPC. And that I had shown. Of course, I have not explained in detail, but we came up with a fault tolerant control based MPC, where we integrated FDA and MPC, state estimator, FDA, and MPC. And with the help of the proposed fault tolerant control scheme, we were able to control the plant. Even in the presence of fault in sensors, actuators, in the presence of mainly soft fault, we were able to maintain the process variable at the set point through the compensation scheme which we had developed. And as a result, your process variable will stay at the set point until we carry out scheduled maintenance. So we came up with a fault tolerant control scheme. So these are some of the applications. And the same Kalman filters can be used to estimate the weights of the neural networks. For example, in the neural networks, normally what we do is that the connection weights can also be estimated using Kalman filter. That is, in train neural networks, it could be feed forward or a recurrent or a deep learning neural network, whatever. So deep neural networks, you can estimate the weights by using Kalman filters, or training. You can train the neural networks, be it feed forward or whatever be the network. You can train using Kalman filters. Another application is target tracking, especially in aerospace. So target tracking is widely used. And another application could be a fusion, sensor fusion, in order to reduce the measurement uncertainty. You can employ Kalman filters. You can fuse different measured outputs, and thereby what you can do is that you can reduce the uncertainty associated with the measurement. These are some of the applications of Kalman filters, Kalman update-based filters, and particle filters. And of course, it's an active research area. Many researchers are working, and then you can come up with new algorithms to generate better estimates. And hot area I would say is distributed state estimation, especially like how to extend all this for interconnected subsystems, where for each subsystem you will build what I would say state estimators. So and then for that you have to take into account interactions and all that. So especially for large scale systems, for interconnected subsystems, now many researchers are working. They have proposed estimation algorithms. So if someone is interested, they can work on distributed state estimation problem, which is a hot area. It could be distributed unconstrained state estimation or constrained state estimation. These are some of the work which research scholars can focus. And these are some of the seminal papers which I have referred. And Julia Ruhlmann 2004 is a benchmark paper. Rollins and Bakshi, it's a benchmark paper where they have discussed in detail about particle filtering and MHE, moving horizon estimation. And then Gordon Salman Smith, it's a benchmark paper, particle filter paper. Of course, Kalman, everyone should refer, should read the paper, Kalman filter, which appeared in 1960. So these are some of the seminal papers. Arundam Palam, and then Vachani. These are some of the seminal papers which appeared in process control literature. And at this juncture, I would like to acknowledge all my research collaborators and financial support, my university also. And jointly with my research collaborators, Professor Sachin Patwardhan is the first author, Shankar Narasimhan, myself, Bhushan and Sirisha, we wrote a review paper which appeared in Control Engineering Practice. This appeared in 2012, and if anyone is interested, you can refer to the paper where we have given a lot of recommendations for the choice of state estimator. So if someone is interested, you can refer this paper. So with this, I would like to wind up my presentation, and if there are any questions, I would like to take.
Sir, there are a few questions in the chat box. Shall I read it out, sir?
Yeah.
First question. Sir, what are the differences if you model a system using one-step prediction and n-step prediction?
One-step prediction and?
N-step prediction.
But
N-step prediction.
No. But that is basically, okay. See, for example, in Kalman filter, we need only one-step ahead estimate. Whereas if you use in MPC, what is required is you need a multi-step ahead prediction, not in Kalman filter. So for that, basically what is required is we should know, in order to do an estimate, basically if you want to do a prediction, basically what is required is we need a model, and then the initial estimate of your state, that is the point estimate. You can use point estimate alone, or you can use the error associated with the estimate. So two things are required. If you want to do a multi-step ahead prediction, what is required is you need a model. Let me explain here. See, for example, if you have a state space model, if you want to do a prediction, what is required is you need x at of at the given time instant, that is x of let's say k plus 1. You want to do a future time instant k plus 1, for which what is required is you need x of k, and then you need uk minus 1, and then if you know the distribution of w, then you can draw samples, and with the help of this, what you can do is that you can predict the value of x at future time instant. So what is required is you need u, x, and w. If you have this, then you can do one step or multi-step, and then you can generate what point estimate. Is it fine?
Okay, sir. And the next question, sir, how do we realize the benefit of quantification of friction in closed loop performance? For example, here flow control loop.
Yeah, there basically what we are trying to do is with the help of this, we are able to suppress the oscillation. So we are able to quantify the friction and provide compensation. As a result, what we can do is that we can avoid this oscillation. So because of friction, what is happening is you see there is an oscillation. So now, after having quantified the amount of friction, then what we can do is that we can provide compensation, which we have not done. That is called friction compensation. So with the help of this compensation, what you can do is that you can prevent oscillation. That's the advantage.
Okay, thank you, sir. Next question. Sir, how to experimentally evaluate Q and R matrices used in EKF for sensors?
Q and R. Okay, so that like for example, so for that what you have to do is like for example, like you have to this basically you cannot do it in what I would say first you can estimate Q, and then say for example if you have a control valve, and if you assume that let me explain here with the help of an example. See, for example, here, let's say how to quantify R. So for that, what you have to do is that you have to measure the value y. You have to measure the value, that is your keep your y constant. Keep y at one particular constant value, and then with the help of your sensor, you try to measure the value of y. Once you have the measurements at different time instant, then you can estimate its mean and you can estimate the variance. The variance is nothing but your R. Okay, so this way you can find what you will be able to estimate R, the variance. R is nothing but the variance. Okay, so you can easily once you have keep the y at a constant value. Okay, so for example, if it is a level transmitter or a level sensor, keep the level at a constant value, and then with the help of your level sensor, measure the level. So your level is constant, that is the true value is constant. You measure your level with the help of a sensor, and then what you do is that you will see that some random variation in the value, in the measured value. So you can calculate the mean and its standard deviation. From that you can find what the standard deviation. So R is nothing but your sigma square. Same way you can find for Q also. Okay.
Okay, thank you, sir. Participants, if you have any other queries, then you can unmute yourself and ask the questions.
Sir, I have a doubt. Sir, for a Kalman filter to be unbiased, okay, one of the requirement is my initial estimate should be equal to expectation of my state. But in real state estimation problem, we do not know our initial state. Then how can we properly initialize?
No, not required actually. See, what will happen? Initial estimate, you will make a wild guess only. Okay, a wild guess, and then because of the feedback, obviously what is happening is it is converging. You can see here. See, in the example which I had shown, so I'm assuming that initially you see that the blue one is the estimated value, and the red one is the true value. See, they are far off. But subsequently it converges. So okay, so there is because of the correction, what is happening is there is a feedback. There is a feedback. As a result, the difference between your predicted value of your estimate and the measurement, that difference, okay, based on that, you are trying to correct your predicted estimate. So a feedback is there. Because of the feedback, what you are able to achieve is you are tracking. That means your estimated value follows your true value. So I don't think, but if it is far off, the initial guess, okay, if it is far off, and if there are constraints, then divergence could happen actually. Okay, so accurate value is not required because no one will know the value. So you have to make a wild guess, and then accordingly you have to initialize your covariance matrix. The initial covariance matrix also have to be properly initialized. If you don't know the true value, then you have to set P to be very large. You will assume that error in estimate is very large. You should not assume P to be very small. Then problem will occur. Okay, you have to assume, okay, P to be very large. That means, which implies error in the initial estimate is very large. So initialize your covariance matrix properly, then you won't land in trouble.
Thanks.
Yeah, next.
Any more questions?
Hello.
If there is no other questions, then we can conclude the session, sir.
Thank you very much.
Thank you, sir. Thank you for accepting our invitation and spending your time for handling this technical session. It was very informative and the point of research, sir. Actually, many people they wanted to do the estimation, state estimation, and other things, but they do not know the basic things about that. But during our session, we have learned those, more information about that one, sir.
Okay, I thank you very much. Thanks a lot. Okay, please permit me to quit. Thank you. Thank you.
Thank you, sir. Thank
Link for the feedback form has been posted in the chat box. All the participants are requested to fill the feedback form.
So participants, the next session will be the
Okay, the participants are requested to stay on the same link. The next session on the topic mental and emotional development by Mr. Jayaraj Hrishikesh will begin by 11:30 a.m.
So participants, a small information about that session. And that session is stress and mental and emotional development and stress management. This session was conducted to promote the Fit India movement across the India, okay, across the country. Okay. For this session, we have arranged the one speaker from Art of Living. The speaker name is Jayaraj Hrishikesh. Okay. So during the session, sometimes the speaker may request you to switch on your video. So you please prepare base certain because I don't know. He may teach some yoga things like that. So if he requests you to switch on your video, participants, please be ready to switch on your video and do whatever he is asking you to do that one for yoga session. Okay. Thank you all. So please join by 11:30 in the same link. Thank you.
Anija? Did you come in?
Good morning, sir.
Hi, good morning.
Okay. Shall we start the session, sir?
Yeah, fine.
Yeah.
We can.
Sir. Yes, there.
Sorry for the inconvenience. I just mute myself. Good morning to all. I welcome all to attend online faculty development program on advanced process control organized by Department of Electrical Engineering and Department of Chemical Engineering, NIT Calicut, sponsored by AICTE Training and Learning Academy. Next, rules and regulations to attend this session. By attending this webinar, you voluntarily agree to the terms and conditions set forth by the AICTE and the complaints of the academy or industry offered this lecture. No contents of this webinar may be copied, recorded, or reproduced in any manner without the written permission of the AICTE and the compliance of the industry offered this lecture. Please mute your mic and camera at all the times. Do not use the chat box for sending personal greetings. Use only to post your doubts on the topic. Do not click present now during the session. If you have any technical issues, please make sure your internet connectivity is stable and then wait for 1 to 2 minutes. If the issue permits, use the WhatsApp group to address it and our team will assist you. Participant must attend all the sessions and a test will be conducted at the end of FDP. Those who get 60% of marks in the test and attendance of above 80% will get the participant certificate. And a warm good morning to all. And I would like to welcome Dr. Kanagalakshmi ma'am to welcome and introduce about the speaker, Mr. Jairaj Rishikesh sir. Over to you, ma'am.
So, good morning. So, on behalf of Patel and the coordinator of this FDP, I welcome Mr. Jairaj Kirikesh. It's a lot of noise from my side. So, let me introduce the speaker. So, Mr. Jairaj Kirikesh received his degree from University of Calicut in 2008. He is the founder and CEO of ThinkSpace Educate Private Limited based on the Kochi, Kerala. It is a cloud-based digital learning platform providing various products for an objective and in-depth assessment of skills required in key learning areas, thereby helping students to improve their knowledge, time management skills, and scores for competitive as well as board examination in core subject. He was a director of TechLayer Software Solution, wherein they focused on online tools to scale offline training programs. He is currently the organizer and technical head of Psychometric Analysis All India Exams. It's an initiative for All India students to measure the psychometric analysis with the National Brain Institute. Sir, on behalf of Atal and NIT Calicut, we welcome you for handling this session, sir.
Thank you.
Thank you, sir.
So, can we start, Kanaga ma'am?
Yes, sir.
Okay. Hi, good morning to all. So, I'm seeing like 89 people are online. What if you can switch on the camera? It will be great help because This is not going to be a normal professional lecture, rather than it's going to be very interactive session, because the subject itself needs a little bit of stress management and a little bit informal communication, right? So one of the challenge we are facing in the online training is making the people switch on the camera first. And I'm basically from Kerala right now. I'm in Gujarat. So I'm also an engineer. So welcome all of you to the program. If possible, either we can use the chat box, or we can right now switch on the camera, so that I can see few faces, and will be nice. Correct. Yeah. Thanks a lot. So hope you all are doing fine and great. One of the things which I noticed when we were last 10 years, I have been training in different various colleges, professionals, directors, and everything. So one of the things which we are facing in today's world, especially after the COVID pandemic, is the management of our own stress, which we carry. So can we all use the chat box to type what kind of difficulty are you facing, maybe after this pandemic? Like, what kind of situations you are going through, which are really making you irritate or depressed, or not that happy. You can type maybe one sentence or a one or two small words, it will be fine. Like, so that we can see what the audience really want to understand. Less socializing. Yeah, Catherine, Dr. Catherine ma'am saying that there is less socializing, hence it will be difficult for people to interact each other, direct meeting. Student mindset towards the exam and test are changing, Anandraj sir is telling. Okay. Negative events, yeah, that normally the trauma which sometimes we carry in our life. Correct. I'm directly coming to the subject, because I really value your time, because all the people are from the premier institutes. Rahul Krishna is telling, logging the research work that I was planned initially. Okay. Okay, something in the career we planned, but it's like it's getting delayed. No stress at all. Good opportunity for online classes. Very good. Govindadi sir is telling it's more easy to handle it from the home. Actually, I am also into that, because I am into online education business. So it's an actually a high in the online education tech industry. Okay. Any more response? Are you all there? All the 89? Very good. No stress at all. So this is what we were thinking was like, normally how we are facing this kind of challenges in our day-to-day life, which is so much related to our physical and mental stress. The first thing is the physical, and which go deep into is the mental. I mean, mentally. So, for example, Bharadam Murali is there. Hi, Bharadam. So right now I am talking something. Where is the mind? For example, I am giving a paper and pen to all of you and telling you to write what are the things we discussed for the last 5 minutes. Like, ma'am was speaking a little bit about me, or I was talking something. So if I'm giving a paper and pen to everybody and telling you to write exactly what we discussed for the last 5 minutes, are you all going to write the same thing or different things? If it is different, can you type D? Or if it is same, can you type S? Can you all participate? It's a request. If it is a different, we can type D. If it is same, we can type S. So it's different. Very good. I'm getting so many S, D. It's same. People are telling same, and people are telling different. Okay, very good. So Pooja is telling same, Bharadam is telling different. Now, see, if it is different, that means what? We all have a different kind of listening ability. The way we listening is different. That's the only problem. So that we understand it in a different way, right? Now, when I am talking right now, where is the mind, Bipin? If I am talking something, for example, you are taking a class, Bipin, you are a lecturer, correct? Or a student, Bipin? Can you type? If you can unmute and talk, then you can type also. JRF. Okay, fine. So the thing is that while you take some program, or you may be noticed that your students are listening to the class, but after 7 minutes, normally it will go for a coffee break. The mind will take a coffee break. It will go to the next room, or it will go for a world tour. It will go to our friends, boyfriends, girlfriends, like that. It will roam and then come back. So it will happen with us when we are attending the program also. I am talking also. Sometimes the mind will go to the past and the future. For example, Tirumurti sir was telling, like, I may be automatically recalling to some past event which is already over. Something happened in the past, and but still I am thinking about that and getting worried. No, with us? How many of you think it is happening with us? You can type yes or no. Yes, 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 it's happening. Rajan is telling yes. Gopinath is telling yes. Dr. Sandeep is telling Rahul, Bharata. Very good. I'm happy that everybody is responding. Like, this happens. How it happens? Like, in the past, something happened, but today also I'm thinking, oh, my life become like this. I would have done that. I don't know all these things, and it will take away the energy, right? So the stress is very simple. That either it go to the past or to the future. Simple as that. It's not in the present moment. Are you all smiling? I can see everybody's face. So, Bhagyalakshmi ma'am, I can see smiling, like Bibin is smiling, Bharadam is smiling. So, are you all smiling? Now, when you are smiling, it means here in the present moment. See how beautifully Sandeep is smiling. Puja, Sangogi. One smile and that's it. Suddenly the environment changes, right? Yes or no? We can see all the beautiful smiles. So, this is what I'm telling. When you are in the present moment, are you all here? Right now here, listening me? Yes. Participant are correct. Yeah. Kangana Masim is supporting for that. Now, when you are in the present moment, naturally there is a smile on your face. If you're not smiling, that means you are thinking something. Either about the past. Oh, what happened in the last year, last month, I could have done that, or I am regretting that I didn't propose to that particular person. I could have applied to that college. I should have done something else in my life. So many things you are planning about the past. That means you are not in the present moment. Are you getting? Or what happened? You are thinking about the future. After when the session is going to over, when Gerard sir will finish the session, what time I am going to have lunch, kitchen mein abhi kya ho raha hai, you know, വൈകുന്നേരം ഞാൻ എന്താ ചെയ്യുക, tomorrow what dress I am going to put, what about my future, will I can marry some good people, will I get salary, what is about my hyping, so many things you are planning about the future. Yes or no? Either mind to the past or to the future, and means it's like going like a pendulum, and that's called the stress symbol. Right? So the is here right now. Yes. How many of you are here with a smile? Can you type yes? Typing yes, you should smile. Why? Why is okay. Yes, yes. How many smiles are coming? So when you are in the present moment, then only we can communicate. Yes and no. Tirumurti is telling yes and no. More sincere answer. I think mind is coming, but still it's going to the past. Okay. So when the mind is in the present moment, then you are naturally smiling. Pandemic situation is telling doctor. That pandemic situation is there. After 1 hour also it's there. So as of now, we will be in this moment. Enjoy the program, and later your problem will not go anywhere. It will be with you. So after 1 hour, we can work out the problem. As of now, just be in this moment But it is very, you can tell that it is very easy to say in the lecture, to say that come to the present. But how? Practically, how it is possible? My mind is into the past, which is bothering me a lot, which is paining me a lot. Correct. Dr. Catherine ma'am is telling time will solve most of the problem. It's right, but it take its own time. Do you need that much time, or do you want to get some tips so that you can come out of it very quickly? We want easy, quick answers, no? In today's world. Correct. So now what happened is, now we understood that mind is thing. Physical pain is okay. If somebody hit you, it's okay. The pain will go after one. But when things happen in the mind, then it takes so much time to heal. Time will take time. So no. It will solve it, but it takes. Now, how the mind and the emotions are connected. Why I am telling so much about the mind? Rakshita is telling be more practical. Yes, I am telling only practical things which I implemented and tested and seeing in so many people. For example, right now when I'm talking, if the mind is not in the present moment, there is no communication will be happening in the between the two people. And most of the issues in the world happens with the communication. Right now, one of the nature of the mind is it is always go to the past and the future. The same nature of the mind is it is always doubting the positive thing. For example, somebody is coming and telling you I love you. Suddenly what is your response? Muhammad Umar, Muhammad Rahman, hi. So somebody is coming, a beautiful girl is coming and tell you, Umar, I love you. Suddenly what's the response coming? Really? How much you love me? Really? So the first is like little bit doubtful. Rahul is telling I am committed, so don't use my name. Okay. So when if you see that the couples are sitting in the restaurant in your campuses and convincing each other, I don't know how many of you are married or not married. So what you said. So what happens, like both are convincing each other that I love you more, because the mind have a nature that it doubt the positive things. For example, the person is telling to Muhammad Umar, I hate you. The same girl is coming in, I hate you. Will you, what the response is? Oh, maybe it's right. Will you ask, really? We can have an ice cream and have a discussion over that. You never doubt it. You believe the negative blamings, but you doubt the positive things. Especially in the students category, why they're like, will I pass in the exam? It's doubtful. Will I fail in the exam? No doubt. Can I do this? There is a big challenge in the campus. Somebody, your director is giving you some challenges. So what do you think? Can I do it? It's doubtful. I can't do it. There is no doubt. Have you noticed this? This is very, very practical thing. Today morning, you are waking up. You are feeling, oh, I'm depressed. You never doubt your depression, but you doubt your happiness. Are you getting this? It's true, correct. So when you doubt your happiness and when you believe in your negative things, then the problem starts, the stress happens. And it become our nature. When you were a kid, you were smiling so many times. When you become a little more teenager, smile. When you become successful, got the degree and a job, now there is no smile on the face. So success without a smile, does it have so much value? So how we can keep that healthy happiness at the same time being successful? That is what we are here to discuss about, right? So the just understanding the metrics of the mind, how it works, its different perspectives, you can actually overcome the mind. If you can manage the mind, you can manage anything. But it's very difficult to manage. For example, I am telling, just watch your mind right now. Or you can keep the eyes closed for 1 minute. Not 1 minute, 30 seconds. Just keep the eyes closed. Everyone just keep the eyes closed and just Scan what are the things coming into your mind, what kinds of thoughts are coming, whether it's a good thought or bad thought, let them be, but let's see what all thoughts are coming into your mind. You can think about anything in the world, but don't think about a monkey, especially a dancing monkey with a brown t-shirt. You can think anything else. Can you just open the eyes? Yeah, open your eyes slowly. Yeah, thank you. Now what is coming into the mind? And there was no monkey, nothing. But the moment I told, don't think about the monkey, suddenly the monkeys are coming, group, family of monkeys are coming, group dancing, everything happening. So this is what the mind is all about. Like the more you control the mind, sometimes it may be difficult to handle the mind, whatever you resist. So understanding the nature of the mind will help you to come out of these obligations and botherations. Now, why I am talking so much about the mind? Because into the emotion. For example, are you all happy right now? Yes or no? You can just type yes or no. Are you all happy? Just happy. Yes. Vimal is happy. Rahul is happy. Bin is happy. Very good. Kandavel is happy. Dr. Kadan is happy. Abbas is happy. Very good. Chama. Very good. Now, how you know that you are happy? Let me see who is answering it. How can we know that somebody is happy? Not sad. Very good answer. If you are not sad, that means we are happy. Very simple answer. Very nice. No tension. Feeling good. Smile. Abbas is smiling. Smile. Yeah. But sometimes you can fake the smile also. Relaxed. About your speech. Oh, by listening my speech, Dr. Bubalan. So, okay. Place peace of mind is there. If you are healthy, Rakshida is telling. Feel high. Okay, fulfilled. Then living present moment without any thoughts. Vimal is telling. Very good. Keeping calm. So right now, no worries. Correct. Now, are you all breathing? I'm telling you something very powerful secret. Pressure. Are you all breathing? Yes. We all are breathing. Now, just observe your breath. Why I'm telling you, you know what is the comfort. Right now, you are comfortable. Now, you know that what gives you so much energy in your life? What gives us so much energy? So much energy. Energy किधर से मिल रहा है हमको? Very good. Positive thought. Shravan is positive thought. Food. Yes. Sleep. Very good. Now, you know that we have to take, as scholars, you know that oxygen. Now, see, we know that as human beings, we have to take food, maybe 3 to 4 liters of food. This much food we have to take so that we will get energy per day. Very good. Some people were telling physical health, physically, we have to do something. Very good. Positive thoughts, right answer. Water we have to drink, oxygen, yes. But you know that we have to drink minimum of 3 to 4 liters of water per day for the energy, but daily we are taking almost 10,000 liters of breath. It's 10,000 liters, my dear. That's a huge. So actually, the real energy source in life is the breath. But are we focused and aware about this fact, the energy bundle of source? Not so much, correct? So what in this session, I have very little time. I have only 1 hour 30 minutes. So within that time, like somebody was telling, let us talk practical. What we can learn practically so that we can understand about the stress and get out of it. Good idea? Yeah. So now why we are talking? Because the breath and the emotions are so much connected. Now many people told they are happy. I'm so happy that you are happy. Now how is your breath? There are 2 breath. One is like incoming breath, one is outgoing breath. Now just observe everybody. Are you happy? If you are not happy, just act like can you just notice one thing, whether your incoming breath or the outgoing breath is longer? If the incoming breath is longer, like, then you have to type 1. If the outgoing breath is longer, you have to type 2. Are you getting? Are you happy? Be happy. First be happy and just observe the breath. I will tell you whether you are happy or unhappy. 2. If the incoming breath is longer, you have to type 1. If the outgoing breath is longer, you have to type 2. Okay. Can you hear me, Bharadam? No? Oh, sorry. One second. What happened? Now? Now the answer is, if you are really happy, your incoming breath is longer. Your outgoing breath will be shorter. Chariot. Incoming breath is longer. Can't hold outgoing longer. Yeah. And the incoming is longer, that means normally the system is happy. Now just act as though you are so sad. You're very sad. You are in pain. You are depressed. Now how is the breath? Now 1 or 2. If you see the very sick, or if you're seeing a grandmother, granny who are very old, they're sick and fever, then what happens, like that. I am not feeling good. The body normally breathe out longer breaths. You see this? How many agree? You can type A. Very good. So the thing is that, agreed. So when you're happy, can you all take a deep breath in and feel that, wow. And when you are, the outgoing breath is, if you are going to acting classes, if you are into the industry of acting and all, then naturally you can understand that how the acting emotions can be bring with the help of the breath. So the incoming breath gives you so much energy and it makes you happy, but the outgoing breath, if it is longer, that means you're sad. Now, can you act like as though you are so angry? Is there anybody here who is thinking that I'm a person who is so angry, I can't control my anger? Anybody is there? You can type me. Anybody who is here? My friend is here. He is also raising the hand. I can control. Okay. Suppress anger. Don't suppress the anger. At times, Shankar is telling, at times I get angry. It's okay. To some extent, me. Varadarajan is telling. Okay. Fine. Based on the situation, Bharadam is taking a safe stand. Very good. So the thing is that, can you get angry, Bharadam? I will show you what I am, right? It is very quick and fast, correct? Very fast. It's like the anger, the moment the breath will be fast. Now, when you're very fearful, you're watching that movie, that horror movie on the television. How is your expression? How is your breath? You will hold the breath, right? Yes or no? How many of you notice this? You're watching that Dracula movie or that Conjuring, which is a horror movie. Yeah, you're watching that. Suddenly you hold the breath. The fear will hold the breath. So, do you understand a beautiful thing? Another thing is jealousy, especially with the girls. I am taking a girl's example. You are going to the college and somebody is coming in a very beautiful Kanchipuram pattu saree, and suddenly something is happening in your stomach. Some breath is going up and down. So the breath pattern slowly changes if you are noticing. So all the emotions in all, when you're feeling love, How is that? How is the emotion? Where are you feeling the love? In the chest, correct? When I say I love you, I keep the hands on here. It's not like I love you here, right? So emotions, where you are in Africa, China, America, or India, it's the same emotions and the same breath which have the physiological and the mental effects on the beautifully designed when you understand how these emotions are controlling the life. Are you getting this? Is it interesting? If it is interesting, please type I. If it is not interesting, then type NI. Okay, can I share some more secrets? Yes, correct. Very good. I am happy for the response. So many I are coming. Nice. Now, the emotions are coming over me, but I don't know how to handle it. If you are especially in the teenagers, I don't know how many of you are, like sometimes you are in some issues and somebody cheated you or something happened in your life, you are heartbroken, but you don't know how to handle that situation. Sometimes you cannot share that with your friends. Sometimes you cannot share that with your parents. Sometimes you cannot share that with your colleagues. You may be carrying that in your heart because it is so painful. I was taking programs in MIT, like Manipal Institute of Technology, and you know that nearly 15 to 20 suicides every year. And after the COVID in the Kerala, I know that this is an all India crowd, but I'm from Kerala, so I'm just saying that the statistics is too high. The suicides are so high. It's not because the people are not talented or the intelligent. They're very intelligent, they're very talented and skillful. But still, what happens? Because it's so difficult to handle the feelings and emotions and the mindset. Are you getting? We know how the WhatsApp work. We know how the artificial intelligence work. We know how the robot works. The latest technology, the deep data, science, everything we know. But it is so difficult to understand ourselves. How I carry myself. How I can be happy. No video again. No video right now. You can see me. What happened? I can see you all. Now you can see video. No. Bandwidth affect by video. Okay. 1 second. Now yes. Okay. Very good. Okay. Now okay. Yeah. So what happens? The emotions are so much controlling the life. If you are looking in the life, in the situations, all these things will be the main things are the feelings and the emotions which will be controlling our life. Right? Now how I will get over my life. For example, today I am wake up in the morning and I feel, oh, I don't feel like going to the college. It happens. Sometimes it happens. No? Even everybody is waiting to raise the hand. If it happens once in a week, it's perfect, it's okay, it's natural, we are human beings. But 5 times a week, if it is happening, like, then there is some issues, right? Yes, so many yes. Now, if you're feeling that, that means there is something, there is a problem with the stress. But if you notice one thing, when you were a kid, when you were like 10-year-old kid, how enthusiastic you were. Very high, yes. How smiling you were, yes. Now, if I am requesting you, can anyone dance like a monkey in front of the camera? Will you do it? The most difficult thing in the world is to request a teacher to dance, right? Especially faculty. So it is very difficult for us. So I'm just sharing one example, like, but when we were as kids, we were so flexible, we were so enthusiastic, we were so loving, we were so smiling, there was so much life in that. Yes or no? So somewhere we are missing that link of the breath and the mind. So what in this session, what we are going to, I just bring the attention back to your basic structure of how the metrics of the mind and the emotions and the breath are so much linked, so that we can work on that. Are you getting this? Good. So for that, what we can do is one practical tool I will teach you. I'm just sharing this tip because when I was in the engineering college, I used to do all these techniques, not in the first year, from the second year onwards, and it helped me a lot in cracking the exams. I was leading the college cricket team, at the same time studies, or getting a placement, or starting my own company, or spreading it across different countries. So all these things, I got so much help because I felt I start controlling my emotions. The emotions are not controlling me. So one of the technique is, it's very simple. Can we all are we all ready to do some small technique? Is it fine? Is it okay? Yes, everybody says okay. Okay, now we understood the problem is, where is the problem. Now we are practical solution what we can do it. Now practically, the so much breath into the system, getting so much oxygen, this can help open all the nervous system in the body. For example, uh, in our college we have different faculties, different layers of faculties, in the computer science, in the chemical engineering, the metallurgy. So if the entire staff is working 100%, then the college becomes so beautiful, right? But normally what happens, 10 to 15 percentage people are working, maybe others are taking rest. Another day, 10 15 percentage of people are working, others are taking rest. So in that way the college may not function 100%. So in the same way, our system is not 100% working. Sometimes some cells are working today, sometimes not. So there are more than 10,000 billion neurons in the system. So how we will make sure that almost everything work, everything is getting enough oxygen, prana, and so that they are ready to do something. So that is possible when you are doing some practical breathing exercise. The breathing exercise become more important after the COVID pandemic. Now people understand that the money will not save them. Only the breath can save you. You can live one day without food, but you cannot hold the breath more than 1 minute. So the breathing exercise and the practical knowledge becomes so important after the pandemic. So what we can do is, it's very simple thing. Normally we are breathing, right? So the same thing we have to do little forcefully, like this. When you are angry with somebody, what we'll do? Like that, no? Can we all make that sound? Do it. Think about that particular person in your college with whom you are in very good terms. Then make this sound. Normally it will come within the department itself, right? We don't have any fight between the other departments, no? Inside our own, sometimes you have funny thing. Like we don't have any problem with the other state people. We have the problem within the family, no? Especially with the relatives and all. Secrets. Sharon is telling it's secrets. Okay, so just make this one. Can you make it? Little forcefully. If you have a towel or something, you can keep it. Something is coming out of your nose, it's fine. That means you are doing perfect. It should be forceful. Make it. Sound is coming. Okay, then you are doing it right. So what we do, we will throw the hands also a little bit up and down. I will show you 1 second. Just adjusting this. So we will sit like this. Are you sitting in a chair without the arms so that it should not hit the sides? Okay. Now what we will do, it's very simple. We will keep the hands like this. And when I say in, we will throw the hands up like this and open the palms. I'll show you this. Like this. And when I say down, out, then it will come back. Very good. Bharadam learned it in one shot. Okay. In, open the palms like this. Second. Yeah. In, out. In, out. In, out. In, out. Simple? Yes, no? So when we are saying in, we will take breath in. Out. So I will do one time for you, then we can do it together. Yes. Like this. In. Clear? It looks so funny. You can laugh and smile, but at the same time, we will do it perfectly. Okay? Can we do that? Ready? Okay. Keep the hands like this. Everybody. Both the hands. Sija. Everyone is doing. In. Out. In. Open the palms. Open the palms. It's very relaxed. Don't play basketball like. It's straight on the top. Very good. Out. In. Open the palms. Out. In. Open the palms. Out. Now people are doing like this. No breath. Not like that. The forceful breath have to come like this. Are you getting? You are doing it perfect, but the sound of breath should come out like a warrior we are doing, right? Like a yodha. Okay. Once again. Keep the hands like this. Okay. In. Out. In. Out. In. Out. In. Out. Very good. Very good. Now I can hear some sound is coming from the mic. Very nice. So what we are going to do, we will do this 15 times. Then we will relax, keeping the palms on the thighs facing the ceiling like this. Again, we will do it 15 times. Again, we will relax. Again, we will do it 15 times and relax. Clear? Vimal, it's clear? Yeah. Simple. So what we will do after doing this, we will do 5 minutes mindfulness meditations we will do. What is this meditation like? Everybody is telling you have to learn meditation. Cricket team is doing, football, everybody, celebrities are saying I meditate every day. So what is this meditation? One word, can anyone explain what is meditation? You can just put your answers. Any answers is fine. One word, what is meditation? Finding void. Very good. Nothing to think. Very good. Being myself. Nice answer, Dr. Katrina. Ma'am, Abbas sir is telling feeling relaxed. Sharavan sir is telling doing nothing, keeping calm inside. Doing nothing is very good answer. Sharavan and Ramaswamy sir is telling. Mind relaxation. Kantimadi is telling mind relaxation. Rhythmic breathing. Good. Feeling space. Bridge is telling keep yourself calm to be in the present state, relax and comfort. Sudha ma'am is telling calm the mind. Bharadam sir is telling relax and comfort. Very good. So many nice answers. Riverside fishing. Okay, that is a for Bibin. It's like a meditation. Not thinking, be in the present moment. Correct. Abbas sir is telling don't think, but it's in the present moment. Mind concentration. Seema ma'am is telling. Nice. Now it's all right. All the answers are right. One the way it's right. But the answer is the art of doing nothing is meditation. If you see meditation hall, there is nothing inside the hall, right? So the nature of the body and the nature of the mind are opposite. The nature of the body is that more you go to gym, you do the exercise, then you develop the shape of the body, correct? Now you make a six pack or you shape it. The more you work out in the gym, you can make that. But the mind works the opposite way. The more you relax, the mind will work better. For example, you lost your car key. What you do? Oh, where I kept, you don't know where it is. And suddenly, oh, you stop all the searching and you sitting, suddenly it will pop up. Oh, it was in that tabletop, correct? As soon as it happens, no? So that's how the mind works. If it is more relaxed, it is more focused. So how can I relax the mind? Now I am telling one more interesting thing you did. I don't want to think about monkeys, but monkeys are coming. You want to study, or today is a very beautiful day. The sun is on the outside, the river, the rain is there, or the clouds are coming, the birds are singing, but the mind is in the past. Oh, something happened in the past, so I am not able to handle the present. I am not able to enjoy the present moment. Now, what I was telling, it is when you are telling the mind to don't think about something, only that will come again and again to the mind. So in the meditation part, we will just observe the mind like an X-ray. If you go through the airport or something, there is an X-ray machine through which the things will go. Like that, you are an observer. You just watching what are the thoughts are coming. Oh, I am now this like a outsider. You are watching what all the thoughts are coming in your mind. So what that we will do. I will guide you. No issues. You have just listen and sit where you are sitting. That's it. You have to do. So we will do the Bastrika. It's called Bastrika. So we will do Bastrika 3 times, then relax. Then we will observe the little bit 5 minutes meditation. We'll do it. Anything? Anybody want to ask anything? No. We'll do it. Then we will discuss. Now, how much more time we have? Now 12:17. Okay. 1 o'clock we will wind up. Don't worry. So much online classes now. Then we will get bored. Right. Yeah. So are you all sitting in a chair or something? Sit very comfortably. Like you can place your entire body weight on the chair you are sitting, and you can keep the hands like this. One thing I forgot to tell you. Sorry, relax. 1 second. When you are doing this process, make sure that your eyes are closed. You have to keep the eyes closed and do the process. Why I am telling you this? Because when you are eating an ice cream, how you eat ice cream? Not when you are in the ice cream parlor. When you are alone in the home and you are eating ice cream, how you will eat? Normally when you are tasting, you will close the eyes, right? And you are smelling a flower. How you smell a flower? When you are alone. Wow, you will close the eyes. When you're listening a song, you put on the headphone in the night, you're just chilling, keeping the eyes closed, and you are enjoying it, right? Keeping the eyes closed. And when you are praying, you are doing namas, or you are doing in the temple, wherever you are, church, wherever you are praying. That time, what you do? You will keep the eyes closed. Or when you are kissing, kissing the babies. When you are kissing the, what you will do? You keep the eyes closed. Why? When you are keeping the eyes closed, you are being with yourself. The happiness and the joy is not in the ice cream, not in the outside, not in the flavor, not in the baby, but it's within me. Are you getting? So I am being with me, then I feel that happiness. So that's why naturally the system is getting the eyes closed. So the experience will be little more deep and intense. Correct? So even when you are doing it wrong, it's fine. I will give very clear instructions time to time. So in between, if you have any doubt, you can open your eyes and see how I am doing. Otherwise, keep the eyes closed and do it. Okay? Ready? Yeah. Okay. Now relaxed and sit like this. Keep your spines. Now get ready for Bastriga. Loose fist in front of your shoulders like this. This is the Bastriga position. Relax your shoulders. Muscle pidikanda. Relax your muscles. Huh. Okay. Smile on your face. Okay. Now we are going to keep the eyes closed. आंखें बंद रखो, कन्नल अड़च्चु वैक्कु. Keep the eyes closed. Okay. Normal breath in and breathe out. Now forceful breath. Breathe in. Hands up. Breathe out. Down. In. Throw the hands up. Open the palms. Out. In. 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 Out. Relax. Hands on your thighs, palms facing the ceiling. Keep the palms on your thighs facing the ceiling and relax. Keep the eyes closed and feel the energy in your body. You can feel there is an energy change in the whole system. You can feel it. Very good. Everyone is doing very good. Relax. One more round we can do. Same position. Loose fist in front of your shoulders. Relaxed. Shoulders relaxed. Facial muscles relaxed. A smile on your face. Normal breath in, out. Deep breath in, breathe out completely. Normal, forceful breath in, out, 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 relax, relax. Very good. Everyone is doing beautifully. Nice. Feel the energy in the body. Now you can feel there is so much energy change in the system. Very good. Relax. One more round. Keep the hands on the sides of the shoulders. Position. Both hands. Make a fist and keep both the hands on the sides of the shoulders. If you have any doubt, please open your eyes and see. Normal breath in and breathe out. If you have any doubt, please open your eyes and see how I am doing. Yeah. A deep breath in, breathe out completely. In normal, forceful breath, breathe in. Throw the hands up, down, out, in, up, down, in, out, 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 in, in, out, in, out, in, out. Relax. Very good. Keep the eyes closed. இங்க பந்து रखो. கண்ணால் அடைச்சு வைக்கൂ. Relax. Keep the hands on your thighs facing the ceiling. Keep the spine straight. Relax the body. Take a deep breath. And breathe out with a bigger smile on your face. And relax the whole body. The legs are relaxed. Your right leg. Take your attention to your right foot, right leg, right knee. Just keep the eyes closed and take your attention to your thighs, right thigh. Take your attention to your left feet, legs, knee, the left thigh. Take a breath in and breathe out and relax more and more. Take your attention to your genital parts, your stomach, abdomen, your tummy, your chest. Take your attention to your right fingers, the hand fingers, the arms, the elbow, the shoulders. Slowly take your attention to your left arm, fingers, arms, elbows, shoulders. Relax both the shoulders. More and more relaxed. The neck is getting relaxed. The face, the head, your beautiful face is getting relaxed. The facial muscles, the eyes are relaxed. The nose, the lips, the chin, the ears, hair. The whole body is relaxed. Take a deep breath in, breathe, and breathe out. Keep the spine straight. Keep your spine straight and your head straight. Hands are relaxed. Your body is a beautiful gift from Mother Nature. Honor and respect our body. Your body is a beautiful gift. Relaxed. Observe the noises in the environment. There is so much noises in the environment. Sometimes the sound of the people talking, the sound of the people walking, the sound of AC or fan. Keeping the eyes closed, just take your attention to the sounds in the environment. The sound of the vehicles, sound of the birds outside. If you are in the home, there may be kitchen sound. Just observe all the sounds in the environment. Observe all the sounds in the environment, and right this moment, you are in harmony with all the noises in the environment. We are in union, we are in harmony with all the noises in the environment. Relax with a smile on your face. One more deep breath. Take a deep breath and breathe out. Observe your thoughts. There are so many thoughts coming into the mind. Sometimes it may be a good thought, sometimes it may be a bad thought. Let them be. Don't judge the thoughts right this moment. Let them come and let them go. Just be a spectator, just be an observer and watch your thoughts. You can see that coming and going and coming and going. Right this moment, you are in harmony with all the thoughts. In this moment, we are in harmony, we are in union with all our thoughts. Take a deep breath and breathe out through the mouth. Just open your mouth and breathe out through the mouth. Take one more breath and breathe out through the mouth, saying ha. Relax. Observe your feelings and emotions. There are so many feelings and emotions are coming up in the mind. Sometimes it may be a happy one, sometimes it may be a depressed one, a sad one. Just observe all your feelings and emotions. Vikarangal, bhav. See that it's coming and going. The emotions, feelings, happiness, sadness, jealousy, guilty, emotions. Just observe. Right this moment, you are in harmony with all the emotions and feelings. In this moment, we are in harmony, we are in union with all the emotions and feelings. Take a deep breath and breathe out. You are love. You are joy. You are love and you are joy. Relax. Observe whether the feelings and emotions are still there. Just observe. Eyes closed, just observe. The emotions are still there. Observe the thoughts are still there. The environment. Observe the sounds in the environment. Bring your attention to the body. Breathe in and breathe out. Relax the shoulders. One more. bigger smile. Even you can show your teeth. Slowly, comfortably, taking your own time to make eyes. You can slowly open your eyes. Beautiful. Some nice, good feel. Whatever you're feeling, you can type. Everybody's doing peaceful. Fresh. Good. Is good. Feel sleep now. Feel to go and sleep now. So relaxed. Yeah. Nice. This is what we really need. Like, relaxing the mind. Is this it's like you switch on the switch back end, the program is running. The body is sleeping but mind is not relaxed, so you don't get that full rest. If you are rest, then only you will come out with that. Sleep good enough, rest, then you come with more energy. Happen, no? So meditation is like super, make you super efficient. Sometimes it happens in my life. I used to study math, but then I used, but then it is more easy to do it. So go for as the college. Okay, right now the you feel so much loud, peace, happiness. It's like a diamond with a, you can see that diamond shine. We all are made up of the same thing called love, or not only the amino acids and carbohydrates, but the enthusiasm, love, happiness, and everything. But what happens? The stress is around this thing. So the moment the stress goes, it is our real uh, enthusiastic life, right? So what we did right now, understand what is around us, help you, doing sometimes. Today, what is my for the last? I wake up in the morning. If possible, I do some exercise, and then before you go to college, you charge your mobile, or before you go for a long drive, you put the petrol in your car. The same way, you get out of your home, you bring dental hygiene. So, are you doing the mental hygiene, doing the meditation, making the mind so much powerful? Seema Baji step minutes small relaxation exercise. I will share. I will give this to Kanaga ma'am, Dr. Kanaga ma'am. I will send you this YouTube 5 minutes, 10 minutes technique. The same thing we did, so that you can in your. Is it okay, Seema ji? Small tips. So every day morning you can take 5 minutes or take 10 minutes. Pause. is deciding whether I should be happy or not happy. I'm not here to motivate you, because motivation is like I give a talk and you feel wow, wow. After my talk, all the motivation will go. The session was very good, but practically it is not helping me in any way. So like Seemaji was telling, like we have to practice it every day. Like you brush, tomorrow also you have to brush. You are taking bath. And every day happiness is choice. The happiness. So every day, 5 minutes, spend 1 hour. Like happiness. Happiness hour is for me. Although people do for happiness and do for others, you have to be. If it is 1 hour, if you wake up early morning, like food, you may be how to rush. So you can do it in also. But if you wake up in the early morning, 1 hour or 30 minutes is good enough to start. 5 minutes is good enough to start. So happiness 5 minutes we can start with. And slowly happiness 10 minutes, then 30 minutes like that. That is selfish in that. It's called MBA, Man Bejao Andolan. You have to save your mind at any. Asking me in the taking a program in a. So I soul, then you will meet your soul mate. So fall in love with your. You can put on. That is the this meditation. Even in Mumbai, people will think. Meditate. Keep the eyes closed. Just meditate. Be your own world. You can do that. Good. So before winding in the session, I want to give you only understand emotional intelligence. I would so much about the emotional intelligence. There was an era where you the IQ, how much the intelligent question, but today's world, so when you are teaching as a faculty or as a student in college, you have to face so many things. So 4 things normally we have to be understand the 4 things. One is mind, that you already understood how the mind should be. It should be stress free, without stress. I shared some understand how your what is intellect do. Intellect judge you, make you confused. For example, today Amma is asking, today your mother is asking, do you want dosa or idli or chapati or porota? So you are confused. So apple juice. This is called intellect, little bit clouded or confused. No, it make you are thinking, I should this career, this college or that college, or I should marry this person or that person. This is called confused intellect. Your intellect is not sharp. Understand that how the intellect is. If you are too much confused with so many choices, that means the intellect is not so sharp. So be careful and be aware how the intellect works. One thing. Believe in the negative things, right? I already told you that. And another thing is the memory. Memory, how it is work. For example, Rashmi Ranjan, are you there? So his smile is so nice, very peaceful person I can feel here. Hairstyle. Just look at his nose. Now what happens? I told 5 good things about Rashmi Ranjan. I just jokingly told about the nose. Now in between, you can see what happened to my nose, right? After 1 year, we are meeting again. Then no. Sometimes, kidding. The nose is also very beautiful. The thing is that we got 5 compliments, but 1 negative things, and we catch on the Session9. We have to understand that how these things metrics works. Very something happened and it and the moment that one something sit breath out stop you go. Now it's clear. What happened? One second. Voice is breaking. Now what to do? We need only 5 more minutes. Voice is not audible clear. Voice is not audible clearly. Now it's clear or still breaking? Okay. Now what will make you uncomfortable in front of the public? For a presentation or something, suddenly you started getting butterflies in your tummy or shivering or this thing. But the same thing you can do in front of your home, in front of your family. You are teaching in front of family, you can do it. But the moment you are with you unknown people, you are with them. See, I feel that all of you are my family members, so I feel so comfortable. Are you getting this? Ego is flexible. When the ego is can play different roles. When you are a teacher in the college, when you are back to home, you are a good husband, you are a good wife, you are a good mother to your kids, to your things like that. You're playing different roles 100%. That is called the flexibility in the ego. Getting? Handling a student in the classroom, you may be a faculty. When you are handling them outside the classroom, sometimes you are a good friend or a good mentor. So understanding the ego, understanding the intellect, understanding the memory, understanding the mind will. This is what I share. So a person whose emotional intelligence is high, that means you have a control over your emotions. How we will get control over emotions? And back to the same thing, that is controlling the breath, doing the breathing exercise regular, you doing the meditations regular. So you know how the circle is completed. Practice this small thing, 5 minutes thing, meditations, exercise. Um, just observing your thoughts, understanding the four things: the breath, mind, intellect, memory, and ego. Slowly, you will have a handle over your emotions and things and the life. I'm not telling tomorrow everything should be correct. No, you are running speed. You are running the car, and when you're putting the brake, stop. Right? Same way, it take few days. It take few times. It may take time. It may take some time, but keep practicing it. Keep doing it daily so that you get in that level of handling. So I am telling you, like, when I was started practicing, it was like, nowadays what I feel is like, if they to make it happy, it's fine. I can sing these things. So the rest is to live a life which we want to live, not a which we have to live. We all dream a life which we want to live, not a life which we have to live. And the live the life with that center of something called that. Then the life becomes so beautiful, becomes so easy. You will create good relations because all the other problems are outside. The moment you rearrange the metrics inside, being aware about all these things, then the life become more easy and manageable. What do you think? Can make us happy. Really, that's what fall in love with yourself first. 5 minutes morning will help. 4 minutes we have. So what we can do is we can just recap or we can just share the experience. Or it was boring. Go to know something new, effective, or it was very practical. Talk, or if you feel like typing, you can share 1 or 2 points. Anything is welcome. But I feel like everybody can share some other point. If anybody want to share live, you are most welcome. Sometimes our ego will allow us to open the camera and talk. Is it like that? See how it works? It's very, very nice the way it works. Now start observing. No, the another mind is telling, don't open the camera. Don't talk. Why I have to? Then I have to click on that. Then I have to click on that button. Then the camera. Then I have now time to observe these things. Whatever we learn, apply it. How this works. Now I have to type. Why I have to type here? Anyway, okay, it's fine. It doesn't make any sentence. Sudha ma'am is telling I forgot my worries for a moment. Wow, nice. I'm so happy that you felt nice.
I mean to say, awareness is the key. So
Somebody's
this
talking.
program, all among this 100,
Hi,
100 people
hi,
here.
Ranjan.
So this awareness and day-to-day practice, at least 5 minutes a time, that will be good for all.
Okay, very good. Vimal is telling again useful things, but the challenge is to practice this 1.5 learning for the rest of my life. Yeah, we will plan some such kind of programs again. 1 hour 30 minutes. Of course, it's not. Maybe like small 1 hour like this in the future also. So we already requested with the AICT to associate those kind of programs with you people. That will help. Correct. Gobinath sir is telling practical and happier. Very good. Anyone else want to share experience? Or you can
Yeah, the exercise was very good actually. Making family members also to do the same, if possible, every day.
yeah, Dr. Badri ma'am. Yes, ma'am. Like we can make them do it. It's very simple, no? Very simple. Only 5 minutes, 10 minutes. You will
Yeah,
feel so
at least
taking
15
a
times. Yeah, at least
15
15
times,
times.
20, 15 to 20 times more than enough. Share you this video so that you can practice it.
Yeah, okay. Thank you very much.
Thank you, ma'am. Okay, Rakul is telling, Rohit is saying thank you, Vimal is saying thanks. Practical. One sentence you can type what you learned from the thing. More useful. Very happy with the session. Thank you. Well, thanks for the particular moment. Sheen Rose is telling. Technical session. Really, we already trained the directors of the ACT and all these programs. So they are recommending this. We should include. Correct, Bipin. It can help in refreshing the mind. In between, correct. Everybody will have their own remote control. Whatever you said in that exercise session. Thanks for that. Reminds me. Good job, Sharavan. Correct. Very nice session. Thank you. Strong determination to achieve success by helping others must give happiness. Gauradas. Feel like a free bird, which feel like a free bird. Happy that everybody felt nice. So thanks for your timing. Ma'am, you are there. I think it's 1 o'clock, so we can wind up the session.
Yes, sir. Yes, sir. Okay.
Yes, Department of Electrical Engineering and Chemical Engineering and AICTE express its sincere gratitude to Mr. Jikesh for invitation to be a part of online FDP and spending his valuable time and efforts in educating the students from various colleges about mental and emotional development. Thank you for giving this great emotional and mental session. Thank you, sir.
Thank you. Thank you.
Thank you, sir. Thank you for your wonderful and very
Thank you.
useful to life.
Okay.
It was a life learning session, sir.
Yeah.
Thank you, sir.
I will share the YouTube links with Seema ma'am. I will share with Kanaka ma'am. Then
Okay, sir.
you can share with others.
Sure, sir. Sure. Thank you. Thank you so much.
Have a good day. Bye bye. Thank you, Seema ji, Kandavel ji. Thanks. Kandimadi ji, Aruna ji, Pooja Sinha. Thanks a lot. Bharadam, Viroshni. Thank you. Ramakoteshwar. Thank you, sir. Nagaraja sir, Committee. Thank you. Pooja Sinha. Thank you. Anandraj. Thank you. Roshni. Thank you, ma'am. Good. Tirumurthy, thank you. Take care. Okay.
Participants quiz sessions will be on 2:30 p.m. Let me check. Schedule. 2:30 to 3:30 p.m. Then after that, feedback session. Okay. So please join the same link by 2:30 p.m. We will share the quiz link. Then you can attend the quiz. The questions will be from that whatever the topic covered in that session only. And then some questions are basic questions from electrical and electronics engineering. That's all. Okay. Thank you all. See you on the 2:30 p.m.